Welcome back to our third session in related rates. And in the second session, we were tackling this problem, this AP question, AP test question. I forget what year it's from, but you got to get a feeling for what you're up against and how tough questions they will ask. But I think this one was this is pretty reasonable question here. We got a picture of the problem. Again, we translated the text into the variables and what was given, what was asked for. Then we had to spend quite a bit of time developing in part B this relationship between volume and the volume of the trough in here and the height of the water. And remember, this is where we came up with this volume is 5/3 h squared. And we needed to know this similar triangle relationship. If we didn't know this relationship here, we're done. We're done. And that's why I'm at the end of this, I'm going to give you some common relationships that are used in these problems. And I've worked a ton of these problems over the years. But similar triangles, you'll see this kind of problem in different places, right? The width to the height is equal to the width to the height of the original triangle or cone or whatnot. Okay, so then we worked this problem. Whoops, that looks like I'm... Okay, then I took the derivative of both sides. I had to work kind of hard to fill in some pieces that I didn't know. I had to find this h. But then in the end, hey, I found dh dt was equal to the minus 2/5 feet per minute. Notice it's negative. Water is being siphoned out. Water's siphoning out, so the water level is going down, which makes sense. Okay, there's a third part to this question, so I guess we ought to get back to that. Let's see what that is. What is the rate of change in the area of the surface of the water? Ooh, the surface of the water. Well, that's this. The surface of the water. That's width. Okay, now remember what that is. Surface is equal to... That's going to be this. That's just going to be this. It's a rectangle, right? It's this rectangle, and its width, this width right here, times a fixed 5. And they're saying when at a quarter volume. Okay. Okay. Let's go to a new page and get that though. So I found out what that surface area of the water, which I guess I could kind of draw it here. That's what this is, and it's going to be width times 5. The surface area is going to be 5 times W. Now what's changing? Remember, water's leaking out of this trough. So the surface area is changing with time because the width is being reduced in time. So they want to know what ds dt is. ds dt is going to be what? Well, do I know what d width is? Do I know that? Because I'm going to need it in here. Well, it turns out, remember that relationship? Where was it here? Where was it? Go back one more. Oh, here it is. Once again, W, from similar triangles, W is 2/3 h. W is 2/3 h. So that was kind of a key, again, key to be able to work this problem. Let's go back here and let's say, okay, this is 5 times 2/3 h. Why? Because W is equal to 2/3 h. And where did that come from? The width to the height does not change. This is from similar triangles. Some similar triangles. Okay. Oh, well, wait a minute. I shouldn't have. Let's not call that the SDT. Let's just call that S. Now, what do I need to do? To take the derivative of both sides, of course. That's the easy part. Now it's, when you get it this far, don't mess it up because you've got it. ds dt, Again, what should the units of that be? Well, that better be feet squared per minute, right? Because that's surface area. This is feet. Okay, well here, let's continue this. I'm getting ahead of myself. 10 thirds dH dt. Okay, so all these, this is a function of time. This is a function of time. We can take the derivative of both sides and we get this. This is feet squared per second. This is feet per minute, sorry. And this is feet. So we do get feet squared per minute. Okay, they asked for ds dt. Well, do we know what dH dt is? We sure do, because we found it on the last problem. It's minus 2/5 feet per minute. Okay, minus 2/5. And this is all going to be feet squared per minute. So this whole thing's going to be what? That's going to go to a 2. It looks like it's going to be minus 4 thirds feet squared per minute. Okay, that is going to be ds dt. Now, it never hurts to read it again to make sure that we get everything. What is the rate of change in the area of the surface of the water? Rate of change of the area of surface of the water. Okay, yeah, they wanted what? ds dt, and we found it. Guess what? I checked that, and we are correct. So, now also, oh, wait a minute. At the instant when the trough is a quarter full by volume. Quarter full by volume. You know, it turns out I don't think we needed that, did we? Let's continue this. It says ds dt was basically equal to 10 thirds dH dt. We didn't need to know what h was, okay? The only thing we needed here was to know what dH dt was, and there's your final answer. Okay, all right, very good. Now you're going to, on an AP test, you get about 15 minutes for such a problem. So you can see we got to get pretty good at these problems. You got to be able to read them, draw a good picture, and have kind of a process. Got to have a process to working these things out. And again, you're drawing pictures, you're labeling variables, you're writing down what's given, you're paying attention to units, and you got to get that relationship, the relationship between what you're given and what you want to find. Okay, so you need to get that relationship between what's given and what you need to find. I'm saying that again, and I will, if you don't know those things, you're kind of stuck. You're stuck in the water. So here I give you a list here, what I call frequent relationships. And there's not, you know, the easiest related rate problems is they've given you the relationship and you have to take a derivative. But those, if you can work the hard ones, you can work the easy ones. But here's one here. The first one I gave you was the following, similar triangles. First time I looked at that problem, I knew I needed a relationship and I couldn't find it. So I needed this thing here. Again, B to H is equal to, you know, the little triangle has the same ratio of sides as the bigger one. We just used this one. Okay, then we worked a problem where triangle trigonometry was important. You need to know your SOHCAHTOA, right? Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is opposite over adjacent. Remember when you learned that about triangle trigonometry. Know your Pythagorean theorem. That comes up a lot, like the ladder problem. Also, they'll give you problems where you have a sphere. They'll tell you what dV/dt is. They want to know what dR/dt is, or the volume of a cone. Remember a cone here. And they'll have, you could have a similar triangle situation in a cone also. Okay, and they will give you this relationship sometimes. So it'll be good to know. 1/3 pi r squared times h. What's the volume of a cylinder? It's the area of the base times the height. Okay, so between these relationships, I think I'd cover most related rate problems you're going to see. Because we could always make an impossible related rate problem has a relationship that's very difficult to kind of tease out from the wording. Okay, but you know, while it's good to work some of those because they're challenging, sometimes if you don't know the relationship, you can't show that you know the calculus. So typically these relationships will take you far. Okay, see you soon.